Hey guys, this is GKCS. It's been a long time since we have made a system design video, and today we'll be talking about designing Instagram. An obvious thing about Instagram is that you can store and get images. So that feature we can assume to always be in an Instagram interview. Now, any other feature is not obvious. So don't jump to what you'll be building before your interview actually mentions it. You might have used Instagram, you might know what it does. However, the interview might be expecting something, and they might know that the time constraints doesn't allow you to dig deep into all of these features. So better ask them, what do you expect? So the interviewer might mention that you want to provide a like plus comment facility for an image. Right? You can also share an image in Facebook. I'm not very sure about Instagram, but let's keep it simple, like and comment on posts. The third thing is you can actually follow someone. So every Instagram account is that of a user. That's my expectation. In Facebook, again, you have a bigger complication that pages can actually be followed. And the fourth thing is you need to publish a news feed. All right, these are the four key features that we have of Instagram. It may not be the most selling thing, but of course, as a system design engineer, these are the things which are difficult to design, or at least these are the basics that we should know when we're doing Instagram. So amongst these, storing and getting images is something that we have already done in our Tinder video. It's in the card floating up there somewhere. So the key things over here is that you want cheaper storage. So you probably go for a file system. You create a CDN over it so that things are fast. And just have a look at the Tinder video to get a better understanding here. The second thing is liking and commenting on images. Now, images are nothing but posts. And the concept of a post is pretty interesting. Can you comment on a comment is a question to ask. So is this recursive? This is a question. Can you like a comment? Now, Instagram does provide you the facility to like a comment. Instagram does not provide you the facility to comment on a comment on a comment. It gives you one layer. So if there is a comment over here, you can actually reply to that, but you can't reply to a reply. So through this, it keeps the level of complexity constrained. Yeah, there's just one level of comment and then reply. However, there's nothing really stopping the system mathematically from making a reply to a reply. But this is an interview, so we'll keep things simple and we'll say that you can't even reply on a comment. There's a single comment you can do. Okay, so no complexities here. You can like a comment though. I'll give you that. You can like a comment. So if you think in terms of the ER diagram of this feature, single feature of liking and commenting, we'll have the likes table being represented as the post which was liked, who liked it, the user ID, the timestamp, at what time did they actually like the post, and is the like still active is one thing, or you can just delete it. Yeah, it shouldn't be too much of an issue, but I'll just call it active or not. Now we just said that likes can actually be on comments also. So the post ID could be useful. It could tell us the post in which the comment existed. But a better way to represent this would be, the only way to represent this, so to speak, is parent ID. Parent ID could be either a comment or a post. So how do I figure out, looking at a like, whether it's from a comment or a post? One of the things you can do is you can, in the parent ID itself, mention comment _123. And 123 could be the comment ID here. Okay, but this is pretty poor design. Instead, what you can keep is a type field. So this type is going to be either comment or it's going to be a post. And using the type, you can tell what type of parent do I have, which tells you where to query in case you want to know what is the original thing which was liked by the user. Okay. So these are the kind of things that we can do with just the like table. What if you need to find the number of likes for a particular post? You can do a select star. Select count star rather. And if you're finding any of this complicated, just have a look at the other system design videos. In fact, you shouldn't be finding this complicated. It's an ER diagram. So yeah. In case you're finding it complicated, I'll mention a link in the description below. It's on databases. So you can have a look at that. Count star from likes where post ID equal to some user parameter. So if you pass in the post ID, I can tell you the number of likes in that post. However, we should be flexible and we should be thinking about things which are going to happen in the future. You need to be able to generate a news feed, and a news feed is going to have a lot of images, a lot of posts that will fire a lot of select star queries. So this is one way. It's going to be damn slow. We are going to ignore this way. Here what you could do is add a column called likes. And whenever there's a like added for a particular parent ID, if that parent ID exists in post, then you increment this likes column. If the parent ID exists, is of type comment, then you increment the likes column over here. However, this is pretty bad design because you have something which is not really relevant to this table kept here. It's an aggregation information which is being stored in the original table for convenience. Okay, so again, we are going to be changing our design a little bit and saying we are not going to be storing likes here. Main reason being that it doesn't belong there. If you have a comment being pulled out, you also have the number of likes over there. Could be useful, could maybe not. Instead, you can have an activity table. And this is going to be defining the number of likes for a particular parent ID. So I'll just call it activity ID, and this is going to be activity ID, and it can store the type too. But do we really need to? No, it's just aggregation. So you don't need to store the type. You could, but you don't need to. What else do we need? Well, the comment is going to have an ID itself. It's going to be having something called textual information. Yeah. Could a comment have an image? It could. You need an image URL then, but right now comments can't have images. And let's try to figure out, there's a timestamp which is always going to be there. Anything else? We have actually missed out something on the likes here. By putting a comment ID, what I should do is I should also put a like ID. Yeah, nearly all tables have IDs. This row is going to be defined using this ID. Okay, a UUID maybe uniquely identifies this row. So it uniquely identifies this action where there was a like done by this user on this activity at this time and so on and so forth. Okay. Now, whenever your system is queried on, let's say, find me the number of likes on this post, it can just go and query this table. Whenever there's a question on find me all the comments for this particular post, it queries this table. Find me all the people who have liked this post, comes on this table. And the queries, I'll mention them in the description below. I'll just, because the queries are mainly database queries. But what we can understand here is that we have designed the system such that the information is available in a nice way. Okay, so this is our original ER diagram. And of course, if you need the post itself, you have the post ID right here. Interesting. Get me all the posts for this user is something that we might do. So the post is going to be having a user ID too. Okay, who has made this post? All right, so as you can see, making an ER diagram is not easy. It's a lot of, changing your tables, understanding how you will be showing that information or retrieving that information. But keep your diagram flexible. Make sure that you're keeping everything which is in future and current in mind. Sometimes you can't, think about the future too much. So in that case, just try to keep your tables as simple as possible. So feature number 1 and 2 are done. The third feature is actually very easy. All it does is a user following another user. So there's two kinds of questions you can ask. The first one being that who follows me, and the second one being who are the people who I follow. So with those two questions, both of them can be answered using a single table. We have the follower user ID, the person who is following someone. The followee user ID is going to be the person who is being followed, that person's user ID, and the time at which they start following. So this takes care of the whole thing. Let's say Gaurav follows Stephen Hawking. All right, at timestamp, let's say today. Now, there's going to be lots of other users who follow Stephen Hawking. So whenever I need to find the people who are following Stephen Hawking, I just come to this column, put a equals condition saying that Hawking and give me all the followers. So it gives you all the followers as a list. Similarly, who are the people who Gaurav follows? Gaurav probably follows a lot more people. There's Bill Gates. So these kind of guys, when I can actually get their user IDs using just a single equals on this column. That takes care of requirement number 3. One of the questions I'm often asked is that during an interview, if you know the answer to a question, should you build the answer slowly or should you just directly give the answer? I believe you should directly give the answer. It saves a lot of time for the interviewer and for you. It's also something that I really appreciate because it shows that the person has prepared well. 2 things which are for this point are that the interviewer is probably expecting to ask you more questions. So this is a simple one. If you answer it quickly, they'll ask you the next one. The second thing is if you answer this quickly, they can get into the advanced topics that they really want to talk about. That is the approach we are taking in this video too. We are not going for extremely simple answers. We are going for slightly advanced system design concepts. I'll be explaining this design using animations because that would be clearer. If at any point you find something too complicated or if at any point you see something that you don't understand, you can always fall back on the system design videos, especially at the system design for Tinder video because there's a lot of things like the proxy and routing that we talk about over there. Since Instagram is a mobile application, it needs a way to connect to our server side. I'm going to be assuming that there's a gateway which is going to be encapsulating a lot of things. The reverse proxy is also the gateway for me because it's going to be deciding where to send the request to. It's going to be encapsulating some security mechanisms like authentication tokens and so on and so forth. One important thing that the gateway can do is it can take external protocols, well-known public protocols like HTTP or sending messages over WebSockets is through XMPP usually. These protocols can be converted to a protocol that we understand. Internally, we might be talking over some other protocol. Now this is just added security so that no one knows how to hit your server using the language that you understand, and that can be done using the gateway. Now when a simple request like get user feed comes in, which takes a parameter of user ID, it will come to one of our internal services. I'm assuming there's a service called user feed service. This service provides the user feed for a user. So that is the top 20 posts that the user needs to look at. It'll be like a news feed. To make this service resilient and also to scale, we need multiple servers running the same service. If you bring in multiple servers, you bring the question of how do I route a request from the user's cell phone to a server in my server side. This can be done using a load balancer. Now it's too expensive to ask the load balancer every time where to route the request. So what we can do is we can store snapshots of the entire system. The load balancer will be maintaining the state of the entire system. It's like a snapshot of all the services and where they exist in which boxes and how do I connect to them. That kind of information is stored in the load balancer, and it keeps coordinating with the gateways and every other service in the system, making sure that they know how to send a request to the correct area. So the load balancer sends this information to the gateway as a snapshot. This snapshot will be periodically updated, let's say every 10 seconds. So when the gateway gets this user feed request, it reads from the snapshot where it should send the request to, which user feed service box should it send the request to, and then forwards that request. I'm assuming that the load is balanced using consistent hashing. So just by hashing the user ID, you can find the box where you should send the request. Importantly, the user feed service is dependent on 2 other services, the posts service and the follow service. The post service, as you can think of, it just stores information about the post that a user has made. So it'll be giving you the posts for every user ID, or maybe posts for a particular day, and so on and so forth. Those are the APIs that it'll expose. The follow service tells you the 2 important questions, answer to the 2 important questions of who are the people I follow and who are the people who follow me. Apart from this, of course, there's a lot of services that I'm just going to be skipping because we have either already spoken about them or they are not core to this particular application, and we'll be speaking about them in future. So just to name a few, one would be the image service. There's also the activity service, which we have explained. There's the chat module. I would say it's not even a single service, it's an entire set of services. And the profile service, which is going to be storing user information like the profile picture, sessions management, and so on and so forth. So there's a lot of things that we are going to be keeping hidden for now, so that we understand the important features that we need to build currently. Now, getting back to the question of how do I find the user feed for a particular user ID, the simple way would be to get all the people who I follow. So get users followed by, and you pass in a user ID that returns the people who are followed by this particular user ID. So if I pass in my user ID, I get all the users who I am following. Once I have this set of users, I can get the posts made by these users. For that, I'll need to query the posts service. Once I run this get posts by user in a for loop, I mean, basically I'm going to be finding the posts by every user who I follow. So that'll be, let's say if I have 10 users who I follow, I'm going to be making 10 requests to the post service. I'm going to be then condensing all that information. I'm going to be converting into a single set and then returning to the mobile application through the gateway. Now there's a lot of wasteful computation over here. You can expose an API which is get posts by users, and you pass in a set of user IDs and you get all the posts in just one go. So that would be one optimization that we can do. The second optimization would be just to limit the number of posts that we are calling out of this post service, because that would reduce the load on the database that it's using internally and reduce the load on the service also. So the network load will reduce. And of course, when we are sending back to the client, that would also reduce the load. However, this is not going to scale. If for every user feed request, we have to recompute all the posts that this person wants to see, it's going to be too expensive, especially on the post service. It's going to get bombarded, and those complex queries that the post service has to do. In fact, most likely you will be ending up doing some joins on the post requests on that database. So it's definitely not going to scale. The correct solution in this case is to pre-compute the user feed. Anytime a user feed request comes in, we just return the user feed in one shot because we have pre-computed it. The only question which remains is, how do we pre-compute? What is a user feed? It's a set of posts that I want to see. What are those posts? I want to see the posts made by people who I follow. Okay, breaking down this problem, it comes to every time a person who I follow posts something on Instagram, we need to update my user feed. So whenever there's a post request from a user, it goes to the post service, gets persisted on the database, and the post service should actually send a notification to the user feed service saying that, hey, here is a post, you should update your pre-computed user feed depending on who are the people who follow the person who has made this post. All right, so what that is allowing is that there's a small incremental update on the user feeds of people who follow this particular user. So if I imagine a few lists of posts, which is nothing but the user feed of user ID 1, 2, and 3, all I need to do is find the user ID of the person who has just made a post, get their followers, and then add to each one's queue. Since the size of this queue is at most 20, this is a pretty efficient way to store the user feed. Now, since we are talking about storage, where should we store this data? Should it be on the database or should it be on the cache? Personally, I would prefer using the cache. The reason for this is because it's going to be separating a lot of the logic that we have on this user feed service. Anytime we lose any kind of data, we can recompute it using the previous brute force formula that we had, basically finding all the people who I follow and then getting their posts. So that would be a one-time thing in case there is a problem with the memory. So when can there be a problem with the memory? Well, if the service crashes, that's fine. It's stateless. It can again recompute. Also, one thing that could happen is you don't have infinite memory, in cache. So what you're going to be doing is the most recently used users will be the ones who will have the user feed served by cache. If there's a person who's logging in infrequently, there's no use wasting memory for them. When they do log in, then we can recompute the user feed for them and then the cache management policies are going to take care of the user feeds for that user. So this is a really nice way. I think what we can do is we can use caches to store the user feeds, and it's going to get to the users very quickly. One interesting thing with this user feed service is that every time it gets a new post, which it has to show to the relevant users, it can actually send notifications to the relevant users. So if there are 2 people who are following user X, then the user feed service will notify those 2 users also. Of course, for this you need either polling from the cell phones. Every 10 seconds they keep polling that is there anything new in my user feed, and so on and so forth. That's a slightly expensive operation, depends on your use case of course, but you can imagine the cell phone taking more bandwidth and more battery for this kind of stuff. You can push notifications from the server using multiple ways. My favorite is WebSockets, but yeah, you can use long polling and so on and so forth. An interesting thing is, how do you route these requests back to the cell phones? And especially when there's just one request coming from the server side and it has to be routed to, let's say, 50 or 60 users who are following this user. So we'll be discussing that in the next video, which is a chat service. In fact, I think I have already discussed a little bit about this in the Tinder video, so you can get an idea over there and you can look for a detailed description in the next video. The final use case is that what if a celebrity makes a post, a person with millions of followers? In this case, what would happen is, if the user feed service behaves in the normal way, it's going to be sending out notifications to 1 million users, and that is going to crash the system more likely, because sending 1 million requests is too heavy a task to be done immediately. There's 2 approaches to solving this. One is batch processing, where you send notifications in a batch of 1,000 people. So every, let's say, 10 seconds you send a notification to 100 people. The next 10 seconds 100 people, and basically you're rate limiting the number of requests you're sending outside. And the other approach, which is very interesting, is that you don't send notifications to the users. You wait for them to pull notifications from you. Now you see these green boxes over here, maybe they are fans of this particular celebrity. What they'll be doing, what the applications will be doing, is that periodically they'll be polling the server for requests. So this is a pull model that we have instead of a push model. The push model always has a problem of fanning out, where there's millions of requests you need to send and it goes crazy. The pull model has the advantage that you can do this slowly, because there's a lot of users who are not going to be pulling at the same time. The push model, of course, has the advantage that it's very seamless. The moment there's a request, you give that notification back to the users and they feel like it's happening all in real time. So in this debate of pull versus push, what you're really looking for is a hybrid model. Whenever there's a celebrity, what you want to do is you want to go for the pull model, because there's too many requests to send. And whenever there's a normal user, you can go for the push model, so that the thing is seamless. In general, this architecture is excellent when you're looking for a news feed. There's a lot of applications which has this: Facebook, Twitter, Quora, Instagram, like we have spoken about. All of these applications require some sort of queue or list in which you're going to be maintaining a size of X number of posts that a person has made, and then you send it to all their followers. With this architecture, user feed services are done. So that takes care of the 4th feature, which is the user feed service. Of course, in a real interview, they can get into anything. They can get into the profile service, maybe the chat module, which I've not talked about. Instagram does provide direct messaging, or they can talk about something like why are you using the HTTP protocol or WebSockets, and etc, etc. But if you can actually come up with these kind of justifications and arguments for the things that you're building, it shows that you understand the system at a good level. Feel free to leave any doubts or suggestions that you have below. If you liked the video, then hit the like button. And if you want notifications for further videos, hit the subscribe button. I'll see you next time.